Today's pre-cal lesson is about vectors, and this is just kind of some basics of vectors, some definitions, and how to do a couple of very simple tasks on this. This is kind of a short unit for us, just 3 days of new instruction, and then we will move on. So part A is just some definitions. A vector is a directed line segment with magnitude and direction. A directed line segment with magnitude and direction. We're going to call the initial point, I'm going to call that P. Initial means just the starting point. The terminal point is going to stand for Q, or Q is going to stand for the terminal point. Terminal means your ending point. And if I draw P, an initial point here, and an arrow to another point, Q, this right here is my vector, PQ. That's just that notated by that PQ arrow. We're going to look at a different notation here in a minute, so don't get too familiar with that necessarily. The magnitude, then, because we said it has magnitude and direction, magnitude is the length found by doing the distance formula. You already know the distance formula, but if I say the magnitude of PQ, that's going to be x2 minus x1 squared plus y2 minus y1 squared. Okay, our notation for vectors, they are bold, lowercase letters. So instead of going by PQ, we're just going to say the bold letter U, or the bold letter V, or the bold letter W. Those are just kind of the more standard ones that we're going to come across, so just be used to that, meaning a vector. Let's look at our first example, number 1. Let U, which is a vector, be from P, which is equal to 0, 0, to Q, which is 3, 2, and let vector V be from R, which is the point 1, 2, to S, which is the point 4, 4. And I want you to show that U is equal to V. Okay, show me that those two vectors are equal. To show that two things are equal, they have to have the same magnitude and direction. We've already talked about how to find the magnitude. Okay, so we're going to show that in practice, and then I'll show you how to find the direction as well. Starting with U, let's find the magnitude of U. So the magnitude of U is equal to the square root of 3 minus 0 squared plus 2 minus 0 squared. 3 minus 0 is 3, squared is 9, plus 2 minus 0 is 2, squared is 4, and 9 plus 4 is 13. So my magnitude of U is the square root of 13. If I want to look at the magnitude of V, I have the square root of 4 minus 1 squared plus 4 minus 2 squared. 4 minus 1 is 3, squared is 9. 4 minus 2 is 2, squared is 4. And again, the magnitude is square root of 13. So in this case, our two magnitudes are exactly the same. Now we need to check their direction. To find the direction of a vector, we want to use the slope formula, which is y2 minus y1 over x2 minus x1. We'll start by finding the slope of U, which would be 2 minus 0 over 3 minus 0, or 2/3. And then the slope of V, which would be 4 minus 2 over 4 minus 1. I'm getting these values from here, y2 minus y1, x2 minus x1. Similarly here, 4 minus 2 is 2, 4 minus 1 is 3. Therefore, that's what those three little dots mean. U, the vector U, is equal to the vector V. Now, That's my whole solution from here on down. I showed that the magnitudes were the same, I showed the slopes or directions were the same, and so now I know that the vectors are the same. The second part of what we want to talk about today is about component form. And the reason I want to use component form is to get all vectors to the 0, 0 standard position. So standard position is a vector whose initial point is 0, 0. If I want to talk about component form, that's a vector in standard position, and its notation is the vector v equals the vector v1, v2. Notice right here I'm using a different bracket that's not the same as parentheses, and that is how I'm going to show you component form, so that will be very important. There is a major difference there. Some other general definitions that we need to look at are the 0 vector, which is notated by this bold 0, which is 0, 0. No magnitude, no direction. The unit vector, call something a unit vector, we'll talk more about that later this week. We're going to call that the vector u, and its magnitude is equal to 1. Think back to the unit circle. Unit means 1, so the unit vector's magnitude is 1, or I force it to be 1. And the last thing is that I can find the component form of a vector v by doing q1 minus p1, comma q2 minus p2. So I'm subtracting its components to find the vector form. We're going to look at one more example, so how to do that in actual practice. Let's flip my paper over here. Okay, example number 2. I want you to find the component form and magnitude of the vector v. That's initial point is 4, 7, or 4, negative 7, excuse me, and terminal point is negative 1, 5. Okay, so I've been given all of my information. I want to find component form and magnitude. To find component form, I'm going to start with the vector v being equal to, and then that was q1 minus p1, so the terminal point comes first, negative 1 minus 4, and then 5 minus negative 7. Negative 1 minus 4 is negative 5. 5 minus a negative 7, minus a minus becomes a plus, and so 5 plus 7 is 12, and that is my component form, negative 5, 12. The magnitude then I can do by plugging in this to the distance formula, or I can take the square root. The subtraction's already done here. So I'm going to do negative 5 squared plus 12 squared. Negative 5 squared is 25. 12 squared is 144. And that's the square root of 169, which is 13. So the vector v, then, to kind of sum it up, in component form is negative 5, 12. And its magnitude is 13. Those would be the two pieces I would want in my answer. That was it for today's lesson. It's assignment number 14, and that was page 456, numbers 1 to 10. Good luck. Let me know if you have questions.